purpose of this video is for you to implement how percent error affects the true values range. A true value is the actual value. Percent error is how an experimental value compares to an accepted value, and a range is a possible numbers or values. Now, let's say Dr. Square has an idea, and he tells his idea to Professor Triangle. Professor Triangle thinks about his idea and then offers Dr. Square some advice. Now, Dr. Square thinks about it and realizes that Professor Triangle often gives bad advice, so his original idea really doesn't change very much. This is kind of how percent error will affect how someone thinks about a value. It may or may not change how they perceive this value. They'll have this idea, and then they'll weigh the percent error values or think about them, and then they may or may not change their idea. Now, this is a visual of how percent error affects a true values range. These black lines are meant to be number lines. The red is the experimental value, and the green blob that comes up is the range. Now, let's start with a low percent error value. If it's small, that means if your percent error is small, that means your range is relatively close-knit around the experimental value. And as you can see, as percent error gets higher, the range of potential values increases. Now remember that the true value that we're talking about is somewhere within the range. It's not the entire range, it's just somewhere in it. This is similar to just how a big earthquake, the bigger the range of how it's felt. Let's say you got an earthquake here. A small earthquake is a small range. The bigger the earthquake, the bigger the range, and the biggest would be most widespread. Now, let's put some numbers with these number lines. Let's say our experimental value is 40, and we've got small percent error values. That means the range of the true value, or the true values range, is going to be very small. It's right around 40. And if you've got bigger percent error, then your range is going to go up. And if you've got even bigger, your range would increase even more. Now, let's compare this to a game. You've all played sharks and minnows, where someone's starts at one point and they need to get to the other side. Let's say Dr. Square is playing that versus an ant. Well, an ant's really small, so Dr. Square could basically run directly across and end relative to where he began. So this ant has minimal effect on Dr. Square. That's like the low percent error value. Now, if Dr. Square plays it against a baby cyclops, that's much bigger than an ant. So where he starts relative to where he ends, he's going to have to spread out where he goes, because the cyclops is bigger, and it's going to affect where his Dr. Square's path more. Now, finally, if he plays it versus Crazy Hair, well, where he starts and where he ends up is going to get very spread out, because Crazy Hair is so much bigger, he really makes Dr. Square spread out where he goes. This is like a high percent error value affecting your true value. Now here's just an explanation of this all. We have our scenario, we had our rulers, and we had our game. The start of these is our experimental value, and in the game it's where they begin. And the influence on these things, in the rulers it's the percent error value, and whoever is the shark in the Sharks and Minnows, that's the ant, Dr. Crazy Hair, and the young Cyclops. And the outcome of this is, in both, the bigger this is, the bigger this influence is, the bigger the range in each scenario. So like the bigger the range of the true value, or the bigger the variety of the paths that the people take. Now, how to calculate a range, it's 4 simple steps. First, you're going to divide your percent error by 100 to make it a decimal. Then you would multiply the value experimental by this decimal, and you'd add and subtract it from your VE. And VE means value experimental. Now, let's say we had an experimental value of 40 and a percent error of 5. Well, the first step is you divide your percent error by 100, so I get a decimal, 0.05, and then I multiply these two numbers. So 40 times 0.05 is 2 grams, or 40 grams times 0.05 is 2 grams, and then I add and subtract it. Now that means my range of values is between 40 to 38, and my true value is somewhere in the middle, or somewhere within that range, I should say.